Hi there, welcome back. So today I'm gonna show you how to create a HEC-RAS model to develop alternatives for floodplain reduction. And basically this tutorial is not related to my previous tutorial that I have already started with creating the bridge scoring. In this tutorial I already have the geometry data, so I'll also share this data in the comment box. I'll give you the link so that you can even practice what I'm gonna do right now. So you'll be able to even manipulate your flow data, your geometry, and your Manning's roughness. We'll see the effect of breeze pairs, number of flow conditions if we just increase our flow boundary condition, if we increase our flow rate, if we just increase the Manning's number, if we even change the debris in between our breeze pairs. So what will be the effect, right, of this different conditions? So this is how we can even select our alternative plans for designing purpose. So that's why this tutorial is very important to even receive your knowledge and expertise in hydraulic modeling. So we are going to do basically alternatives, right, for floodplain development and floodplain reduction technique. So I'll select one study area that is located in southwest here, somewhere there, of Houston city or Houston area. Basically this area mostly farmland with a sparse population. It is not that urban area, and it is fairly flat with some trees and low shrubbery, but most part of the area is widely open farms. And there is no, you can see there is very little rainfall, and the water is not that very high. It's average flow rate we have for this streams. It is called Big Creek. So I'm gonna share this data with you. So at first what I have to do, I have to open that HEC-RAS. It is version 6. I already mentioned how to download and install, right? So I already have the file. I'm gonna open that project where I already posted. It is in my D drive, and it should be there. It should be Big Creek, okay, that one. So I have the project. I just have the geometry. Then I'll even modify the geometry, and I'll share with you this basic data I have. And out of this data, you can even manipulate the way I'm doing right now. And then you will be familiar more with this software. Okay, so these are the cross sections we have for this area, but I'm not going to even interpolate these cross sections. And within this reach of the river, Big Creek, we have two breezes. We have two breezes here. One breeze is there, and another one is here. So if I'll show you how to add this breeze from the beginning in my other tutorial series that I already started. I uploaded part 1 and part 2. So this is another one where I'm going to show you how to even change different conditions and study the effect of different flow conditions and different input parameters and roughness and so on and so forth. You will see at the end of this video what I'm going to do. Okay, so we have two breezes. I'm going to show you that if we click on that breeze, so you'll see we have one breeze there, here, that is the breeze. You can see the cross-section number, and if you go down, it will show you another breeze here. So we'll modify this breeze, and we have two breezes, right? And we'll remove one breeze, and we'll see the effect of removing one breeze, because if you add your breeze and if you don't maintain the distance, right, minimum distance in between two breezes, then what will happen? There will be some effect, right, backwater effect of one breeze, right, downstream breeze on upstream breeze. So that's why even if you may have the effect of upstream breeze, right, on the downstream breeze as well. So we'll test this one today. What is the effect of these breezes? And if you just increase the number of pier, then there will be, right, the flow will be constricted, and the conveyance area will be reduced. Then there will be some issues, right? So what will happen? I'm not gonna tell you right now. We'll see. So the first step, this is the basic condition we have. So we have this geometry. Let me just show you. And at the end of this video, for the final condition, I'll show you the effect of interpolation of this cross section. You know, right, how to interpolate cross section. So today I'll show you how to interpolate cross sections in between two sections, and also will interpolate for the entire reach of this river. So here is the section. You can see at the same time it is locating the circle, this pink circle, that is the very upstream. You can see the number of the cross section, and if I go down, see, this is the section. You can see this is a creek. That's why this is the floodplain. This is not the actual river. Most of the river in USA, these are the creek. It is pretty deep and the width is not that big, right? It is a narrow channel. And this is, see, the bridge section. These are the sections we have, and that's it. So what I'm going to do, I'm going to change the condition because we already have the flow condition here. Since it is steady flow condition, I'm going to show you that one. So if I go to edit and then steady flow data, you will see that we have the data for 100-year of flood period. In my last video, I already mentioned, right, how to calculate this flood frequency analysis, how to do that, how to perform that flood frequency analysis, and how to calculate the 100-year return period of water level and flow rate. So this is how this is calculated. But what I did, I added only one flow rate at the very upstream. But here the benefit of this tutorial is that I'm gonna add many, right? Not only one flow rate at the very upstream cross section, but I added many flow, right? We have different contribution. See, at the very upstream we have this 4,000. This is the 100-year flow, and in another cross section you can see the next one. We have one tributary that is connecting to that location, so we have this water. And if you go downstream, right, we have another one there, 19, that section. Here we have another flow contribution, and then 005, right here we have another contribution. There we have another contribution of flow, and at the end 174, here we have another flow contribution. So this is how we are just adding. If you need to even add, you can add here multiple, and you can add from there, right? We have this, we just added this way. So we have this flow condition 100 here. So if I run it, yeah, I can run it, and then I'll change this flow condition. At first, let me run it with this one, and let me check the boundary condition, right, as water level. So they're using the same thing, known water level. These are the basic condition. I'll give you that one, and from this one we'll modify everything. Okay, so the known water level, they're giving 51.6. okay, 51.6 feet, not in meter. In USA we use basically the customary unit in feet. So the previous videos I mentioned already, that is in meter, so you can even learn both meter and feet, not a problem. So what I'm going to do, basically I'm going to modify the boundary condition, and I'm going to change the, how can I modify this one? We have only one profile, right? If I select 3, and if I just click apply data, it will create 3 different columns, right? So now I'm going to increase these flows by 25%, and then I'll even increase this by 50%. How can I do that? So this is another new technique you're going to learn today. So at first I'm going to change the name, right, so that we can even make a track. So that one, edit profile, and then here it will be flow, 25%. okay, means we'll increase the flow by 25%, and here we'll increase the flow by 50%. okay, how can you do that? Yeah, definitely we can do that. If we multiply this one by 1.25, it will be increased by 25%, right? The same thing. So I'm gonna do it at once. So I'm gonna copy and select and then paste. It is there. While selecting this column, I'm gonna click on options and then ratio selected flows. And then if you multiply this one by 1.25, it will be converted to, right, that flow that increased by 1.25. And similarly, if I just copy again and if I paste it there after selecting that one, and while selecting the entire column, I'm gonna go to ratio selected flows, and this will be 1.5. So it will be increased by 1.5 times from this one, right? So we have a new flow data with 3 different profiles. So what I'm gonna do, I'm gonna save it. I have to save it, right? Save it as different name. So that's it. So save the flow data as not existing. So it will be, oh, okay, we can select it by existing. It is not a problem as well. Okay. yeah, we can override that one for this case. So we have the original flow data. So we are done with this one. Yeah, what do you have to do? I have to change the run condition, right? So steady flow analysis. Here, I have to even select the geometry. See, we have the geometry that is the existing one. I didn't do anything there, but in future I'll do that. I'll interpolate at the end of this video, and then I'll even add different pier in the breeze, and I'll remove the breeze, and even I'll change the boundary condition at the downstream water level as well, right? So I'm not gonna do anything. I just change because I'm testing different condition. So in the next step, I'll even I'll change the downstream boundary condition, but this time I only increase the flow rate by 25% and 50%, and I'm gonna select only one, right? The existing steady flow, we have the data we just saved there. And if I want to save the plan, what I have to do, I have to even write existing, right? Okay, existing 100-year plan. That's that. And what will be the short ID? I'm gonna exist and 100-year. Okay, that's the short ID I have. If I click OK, so I have the saved data. So what I do usually, I just select that flow distribution location so that we can see the velocity distribution is time, right? That looks nice. So this is why I'm just selecting this one is time and run the model. So I'm clicking OK, I save the plan. Even I can save it because I changed that one, save plan. And if I run it, it will start running if everything is okay. Definitely, I'm hoping everything is okay and it's gonna finish. See, it's pretty quick and it's the time, right? We'll compare. So each time I'll run a condition, I'll even save the plot, right? As I'll add the plot in doc file, and then we'll compare and we'll make some comments. And basically this will be kind of a model simulation and data analysis as well, because if you are able to run the model, but if you don't know what is actually happening, and if you don't know how to interpret this result, so there won't be any, right? There won't be any use of these results or modeling. So you have to know how to interpret these results, and you have to be able to decipher the hidden things that we have here in this modeling. So I'm done with that. So now it's time to investigate the cross sections and flow profiles. If you see the cross sections, right, this is the cross section. If I just click, and you can see the cross sections, and that was the breeze section, right? This is the upstream breeze we have. See, we have the highest or maximum velocity there, 4 feet per second on the left side of this, right, pier. So that is another possible reason that, okay, we'll have more scouring there. And if I go to the next breeze, right, so let's see if we can find that. Definitely we have the breeze, it's coming. So that is another one. This is another breeze. We have one pier. See, the velocity is 8. It is even more than that, so it's pretty high, right? So we can even copy the downstream breeze. This one, we can copy the cross section. That will be useful. Okay, at first we'll follow the guideline. We'll copy the long profile, right? We can see that this is the long profile we have. Even if you want to see the perspective plot that we saw, go to view, and that perspective plot, you can see we have 2, right, breeze there. And if you want to see different changes, you can see that this is how we can change it. That is the upstream breeze, that is the downstream breeze. We can see all of this. Okay, so we can even copy that one as well. It is not a problem. So I'm not going to copy this one. I'm going to even compare the profiles and the cross sections, because it is related to the velocity and the height of water surface elevation. Okay, so here you can see we have only one existing 100-year flood profile, but if you want to add more profile, because we already have, right, 25% increase of flow rate and 50% increase of flow rate, how can you see that? So here, go to options and then profiles, and here we only added, right, by default it added the first profile. So if you want to add, select all, it will be there, and you can see the increase, right, this change. If you increase your flow rate, definitely the water surface will be increased. But the most interesting thing, can you find that here? This is the downstream breeze, and that is the upstream breeze. So the upstream breeze is so high that it is not even submerging, right? It is not submerged. But what about downstream one? See, this breeze, it just got submerged, and you can check that, right? If 50% first, the existing profile, see, it is the water surface profile. If you see 25% increase, it is increasing, right? And if you check 50% increase, it is higher than that. So that's why if you increase your flow rate, you have to even increase the breeze height, right? Height of the breeze, otherwise it will be submerged. And if you zoom in, you can see that even with this existing condition, the downstream breeze, it is just submerging, it is overflowing, it is even getting flooded. So that's the one condition we get, and we don't need that. So we are going to compare everything. So I'm going to copy, okay? I'm going to copy that profile. So this profile, go to option or file and click plot to clipboard. And then I'm going to open a new Word, and you can see that, okay? I'm going to paste it pretty quickly there. So we have this plot. Okay, I'm going to even show you this way so that you can understand. So we have this, right? That is the existing plan. And next we'll plot another one and we'll paste it just below this one so you can compare what is actually happening. Okay, so that's that. And at the same time, I'm gonna even copy some plots of cross sections, especially the breeze one. Okay, downstream breeze. So this is the downstream breeze, and this is from the upstream part of the downstream breeze. So if you see in the HEC-RAS model, you have to even enter the breeze section, right? Two different way. It will have one upstream section and the downstream section, because the breeze of the road, it has some width, right? Like 20 feet or 30 feet, whatever the number of lengths of the road. So depends on that one. So the width is different. So there will be different calculation. The upstream is covering, downstream is covering, and upstream shape of the pier is maybe different than the downstream one, right? And we may have different pier as well, and there may be one single pier, but it is totally different. In this model, we even enter it separately. This, okay, I'll show you how to add the breeze pier, but now I'll show you how to even increase the number of piers as well, and I'll explain there. So I'm going to copy again this plot. So it's time I'll do something, but most of the time I'll copy the profile and I'll compare what is actually happening there if we change our condition. Okay, so that would be good here. Okay, I'm going to open a new. That would be a good idea to compare this cross section and the profile in two separate files. So we are done with that basic condition. We added our flow rate, we increased the number of, right? Now what we're gonna do, we're gonna even delete the breeze. Okay, so what will happen if we remove the breeze from the downstream side? Then what will happen? We'll check that, right? Because breeze is an here, downstream breeze, you can see that, right? If you see, this is breeze, or even we can remove. Okay, since we are gonna update everything for the downstream breeze, so we are gonna remove the upstream one, and let's see what will happen to the downstream breeze. So that is the most important thing. Okay, so we are gonna remove the upstream breeze. How can I do that? This time we'll modify our geometry. Okay, so here it is. If you click on the breeze or culvert, so it will open the breeze section. So you have to identify which one is which. So that is the downstream breeze, and that one is the upstream breeze. So we are going to remove that one. How can you do that? So go to file or view or option. You can find every options you have here. You can add new breeze. You can copy the information of this breeze, and you can even delete the breeze. If you delete it, okay, it will be deleted from the geometry. Okay, so there is no breeze right now at the upstream section. You can see if you open it, and not this one, the breeze, you'll see only one breeze we have. There is nothing. Okay, so we have new geometry. So we're gonna save the geometry as, okay, so this one will be downstream. Okay, downstream breeze means single breeze, downstream breeze. Downstream breeze and single. Okay, and single. So that is the geometry we have right now. So now we'll even run with the same flow condition we have, but with the new geometry. So that's why what we have to do, we have to even modify our run condition, right? We are not going to change our flow condition, we are going to change our run condition. So here it is. If I'm going to see, we have the new geometry and we also have the existing geometry. So I'm going to use the new geometry but the existing flow condition. This is the flow condition where we have our 100-year flow rate and we have 25% increase and 50% increased flow rate. I'm going to save this plan and it is asking, okay, what will be our new name? Okay, it will be the existing 100-year, and then I'm going to give the name as single breeze. Okay, DS single breeze. Okay, I'm just giving the short name BR, okay, so that we can even follow that way. And I'm gonna click OK. It is gonna ask, so I'm gonna give the short name 100-year. Okay, 100-year existing exist. That's it. So we have our new condition. So we already added that one. If I hit compute, so it will compute and we'll see the changes. So this is another condition I'm gonna do. This is how I'll compare, right, one condition with another one. So we already have the simulation. Let's find the long profile, right? So we are having this 3 profile. I'm not gonna see the increase. I'm not gonna interested anymore with that increase 25% or 50%. We already have idea about if we increase the flow rate, the water surface elevation will be increased, right? So you know that. So I'm gonna remove that one. I'm gonna keep only the initial because that's the one we need to focus on. So we have only one, okay? So that's that. So how can you even compare with the previous one? So that is the option we have. That's why we are going to do this. If you go to option and if you go to plans, and then here we have now 2 plans. The other one is the existing one and the latest one is this one with, right, breeze, single breeze. If you click OK, it will add that. So can you see that? Now we have 2 plans, right, superimposed, and you can compare, right, what happens. Previously we had 2 breezes, now we have only 1 breeze. But let me check that. If I zoom in here, what actually happens. If you click there, right, the water surface elevation, so that is the water surface elevation, right, 100 here. This is the existing 100 here, right? You see that? Yeah. And what about the water surface elevation existing? We already have idea about that one, right? So we have critical energy, we have, because we are using the same flow condition, that's why we have the same name. But can you see that? So this energy level existing, this energy level existing, we have 2 different things but by the same name. But what we are going to do here, we have, see, but the problem, we can find out what we are comparing there. We remove the previous breeze, right, and we can compare with the previous image. So I'm gonna even, okay, copy that and I'm gonna paste it, then you will see what is gonna happen. And even you can compare your flow data if you wanna see that using your numerical value. Even we can do that. I'm gonna copy it and then I'm gonna paste it, okay, just below this one, and you can even compare side by side if you want. So that's it. If you see what happens, you can you see that it is the minimum value. It is even, it was close to in between 55 and 50. It was like 52 or something like that, because the downstream condition is 51.6. So it is there, right? But what about the upstream one? Can we just count that one? No. So we have to go to our table, summary table there. Here, if you click there, table, you'll get everything, right? What is the water surface elevation and everything you need. Reach number 1, and you can find out the location. So breeze 2, we're gonna focusing on the breeze. Here we have the breeze section. We have that breeze, and you can find, right, we have 2. See, we have 2 different profile. So we can you see that? If I close that, this one 100 year exists. It is the new one with single breeze, and exists 100 year. It is the previous condition. Can you see that? Everything is, top width is same, and here everything looks same. But what do you have to do? Water surface elevation, right? This one, water surface elevation. We have to focus on that one, right? So for this case, see, it doesn't have any effect there for the same flow condition. Everything looks same. So if you remove the upstream breeze, because the upstream breeze is located far away from the downstream breeze, so it doesn't have any backwater effect, or it doesn't have any effect on that one. So it's okay. So downstream breeze doesn't have any backwater effect on the upstream. So that previous profile and the new profile, these are same. So we can find out that way. It doesn't have any effect. However, the breeze is still, right, it is overflowing. You can see that, right? It is overflowing, it is submerged. So within this condition, the downstream breeze on sustain, it will be flooded. So we have to even increase the height of the breeze. So that is one we got, right? It happened previously, so there is no change. So now I'll even I'll change the downstream boundary condition this time, because the downstream boundary condition, we use the same for the two runs. Okay, so now I'm going to change the downstream boundary condition. How can I do that? That's why we have to go back to our previous, okay, that edit and then steady flow data, and here it is, flow condition, and click on that known water surface, and here we are going to add 2. Okay, we're going to add 2 feet with this one. If we increase, so I'm going to see the effect. If we increase the downstream boundary condition, means water level, if we increase the water level by 2 feet, so what will be the effect, right? And we'll compare with the existing, means the previous or the first geometry that has 2 breezes. So it will be 53.6, and I'm gonna even change all of them, 53.6, and it will be like 53.6 as well. So that is the effect of this one. So we have to save it, right? This flow data, we change it. So I'm gonna save this as existing 100 here. Okay, I'm gonna change this that way. I'm removing the white space in between this name with this, and then it will be 2 feet. Okay, it will be 2 feet downstream. Okay, DS, downstream condition, downstream water level. Okay, this way I'm changing. So we have this one, we're done with this one. So I'm gonna change the run condition as well. So we are gonna select the previous geometry, the original one, because we already tested the single breeze. We're not gonna see that. We're gonna compare, right, the existing with our new, see, the flow data, not the previous one. So that is what I'm gonna test. And if I wanna save it, save the plan, it is gonna ask. So it will be this one. I'm gonna follow this one. Okay, existing, so 2 feet, it will be 2 feet. Okay, 2 feet down, 2 feet downstream water level. That's what we increase. So I'm gonna track that way. Okay, if I click OK, so it is gonna ask. So it will be 100 here, 100. The previous one starts with exist. So my new condition is, right, it starts with 100 here, and then exist, and then 2 feet. So that is for 2 feet. Previous one was the original one. So that's that. If I hit compute, see that it's gonna run pretty quickly, right? And let me compare the result with the previous condition. So if I wanna open the profile, most of the time we're gonna change the profile. See here, if we increase the downstream boundary condition, and what is happening? See, the breeze, the downstream breeze, it got flooded, right? More flooded. So if you increase the downstream water level, definitely there will be backwater effect, and your breeze or the upstream area or floodplain will be affected. There will be more flood because of the backwater effect. So if I want to change the plan, if I want to add the previous one, see the basic one with this increased 2 feet, then you can see the difference. Okay, you can see that. So the first one was what? See, that is the existing condition. If you increase 2 feet, the water surface is this one, right? So definitely water surface is increasing and the breeze is submerging. So we have to be careful about that one. So these are the effects. That is what we are testing today. If we manipulate our result, I'm going to paste it, right, for the factor of safety, so that in future we can even compare and check. So this is the data analysis part, you can even check this, see, and the exact value. If you want to check the exact value, so what will happen, click there and again check the breezes, because we have two breezes. That is the first one, right, the upstream breeze, and you have two conditions here, right, the initial existing condition, and if you increase the 2 feet, can you see that the water surface, is it same right now? Can you check that water surface elevation, is it same? Definitely it increased. Previously it was 55.43 and now it is 55.92. The water surface elevation increased. So how much it increased, you can calculate the difference between these two, right? So that is the difference between these two, it increased. And if you want to check, right, the fluid number, previously it was 0.1 and then it got reduced to 0.09. That means the velocity of water got reduced. So that's why the flow is subcritical. Previously even it was subcritical, but now it is also subcritical. Okay, and even you can check the slope, you can check the velocity. See, the velocity of course reduced. That's why the fluid number got reduced, right? So this is the information you can get from there, and you can see since the water surface elevation increased, the convex area of the flow area increased. Since flow area increased, we know the Q is equal to AV. Q is also same, so A increased, the velocity is, right, velocity decreased, and you can see the top width also increased, right? If we just add 2 feet of water level, right, with the previous one, and you can check. So this is gonna, so the same situation, right? The situation is same for the downstream breeze as well. See, you can see the previous one was 53.75 and now it is 54.63. So the effect on the downstream breeze is more prominent than the upstream breeze, right? The effect of flooding. So you can see the same thing happened here as well. Top width increased, the flow area also increased, and the velocity got reduced. Previously it was so high, but now it is 1.76. So these are the information you can get, and you can even plot the cross section as well. Here we are plotting that one, right? So I'm gonna save it to show you the difference between these two. And while writing your report, you can even copy this way. So the most important thing about, or the benefit of this software, is that it stores everything, right, as a backup, and you can just get back to that plan or profile to add and compare, right, within this graphic user interface. So that's the benefit we have. Now I'm gonna change another condition and let's see what is the effect of that one. So instead of using that non-water surface elevation, if I change the downstream or downstream boundary condition from non-water surface elevation to critical depth, then what will happen? Let's see. Okay, so I'm gonna even change the flow condition, not the geometry this time, and here it is, steady flow data, right? What do we have to do? We have to go to there, and then instead of that non-water surface, we're gonna click critical depth. For critical depth, you don't need to provide any data, so that is the benefit you have. If you click there, we have the critical depth and it's there. And what I have to do, I have to save it, right? Because I'm gonna use that one. So save the flow data as, so that is 100 here, and okay, so I'm gonna add it. Okay, if we use increase flow condition, or okay, let me just remove that first. Okay, remove that first, then you'll see okay, we don't need anything, so it will use the previous one. I'm gonna save that as critical. Okay, we don't need that existing with critical condition. Okay, so that is the critical depth condition. So if I click OK, so we saved the data, we have that the condition. Now I have to change the run condition as before. So the geometry will be existing one, however the steady flow data will be critical depth. So we change the flow, right, downstream condition here. So I'm gonna save the plan as before, so that will be this one, critical. Okay, 100 here, and then critical, that's it, and it will be 100 here, exist critical, CR critical. Okay, this is the short name I'm gonna give, and if I compute, see, So this is the benefit of this software. You can change quickly and you can get the result. But for any other model, you have to wait for a long time and then you'll see the result and then you have to change one. So that is a really time consuming task. So using this ACC software, these are pretty convenient from my understanding, and other people says the same thing. So here it is. If I close that one, I'm going to open the long profile, and can you see that? See, it's pretty nice, right? The critical, so it is missing the critical point here. And if I want to compare with the previous plan we have, so we can even select that one, okay? And that's it. So previously what we had this one, but if you select the boundary condition as critical, so your downstream profile will be this one and your velocity will increase, right? So that's that. So that is the existing one, and if you use your critical, so that is the line. And I'm going to copy that. I'm going to paste it in my Word file to compare between these two. Okay, here it is. And yeah, we're just increasing the number of plots. So by this time we already tested the basic condition of the existing one. We increased the flow rate, and then we increased the downstream water level by 2 feet, and then we changed the downstream boundary condition from non-water level to critical, right? Now what we have to do, I'll change the condition and even I'll add more breeze pier. So we are now gonna increase the abstraction and let's see what happens. And at the same time, I'm gonna copy this cross section as well so that you can even store, you can follow the steps I follow usually. And I'm gonna even paste it there. So we have this nice plots for the same section, right? You can see that the velocity almost same. And okay, now what I have to do, I have to go to this breeze. If you click on the breeze section, culvert, we have 2 breeze, right? Do we have 2 breezes here? Yeah, definitely we have 2 because we are using the existing. Okay, so I'm not gonna do anything right for this off-stream breeze. We can keep it as it is, and if you wanna, by this time you'll know how to change different condition, you can see that. But for the sake of demonstration, I'm gonna change everything right for the downstream breeze. So I'm gonna add, we have only 1 pier there. I'm gonna add 1 pier just before this and after this pier we have, right? So how can you do that? So I'll show you how to add the breeze from the beginning, but this is another step. It is the same. If you click on pier, so how to add breeze, it is a matter of this one. You have to have all this information. So I'll show you, show you that one in my continuation of the previous tutorial that I'm gonna finishing. So here I'm gonna focus on the piers. Okay, here if you click that pier, we have only 1 pier, right? And what I'm gonna do, I'm gonna keep the size, shape, width, elevation, everything same, but I'll increase the number. Okay, and then I'll put some kind of debris in between this pier. It will be the next condition. So if I copy, say the number changed to copy, but the center line, you have to change the center line based on the center line it will place, right? So that will be this one. So because it was 100, right? So if I want to put another one, so it will be 80. And if I just click OK, so it will add 1 pier. Okay, I'm gonna add another pier. I'm gonna copy this one, and it is number 3. So what I have to do, because previous one was 10100, so that will be 120. So it will be the spacing right uniformly. So we have 3 piers. You can increase the number, not a problem. So we increase the pier, we are exiting that one because we changed the geometry. So now I'm going to save the geometry again as, so we have the geometry, existing geometry, right? With what? Okay, this time even I can remove the white space. That is the rule I follow usually. So that will be 2 piers, okay? Two piers. And let's see what is the effect of adding these 2 piers, because when we added this pier, that means the flow area, right, got restricted, and there has been reduction of conveyance area, right? There will be constriction of the conveyance area. So we constricted the flow, and let's see what's gonna happen. So now I have to change the run condition, not the flow condition, because I'm going to use the previous flow condition. Which one is that? The existing condition. Okay, I'm not going to add 2 feet increased of downstream water level. I'm not going to use the critical boundary condition of the downstream water level. I'm going to use the existing one where we have the downstream water level at 51.6 feet, and we also have the water level 100 here, and we can even exclude the 25% increase and 50% increase. It doesn't matter. Okay, so I'm gonna save it, save the plan, and what will be the name of the plan instead of that? So what it did, basically we added peer. Okay, existing, so that will be, okay, I'm gonna select this type, existing 100 here, with 2 peers. Okay, with 2 peers, 2 peers. So let's see what we have. So it will be 100 year. Okay, 100 year exist and 2 peers. This is the short name I can give, and if I hit compute, it's gonna run, and let's see what is the effect of increasing the number of peers. Okay, so here it is, the plot. We have the long profile, and if I even add the previous plan to compare with that one, the existing one, and let's see what happens, right? See, still the downstream bridge is over flooding. That's the rule, because we have to even decrease or increase the bridge. We're not going to change the elevation right now. We're going to see the effect of other conditions, that, right? So what's going to happen here? You can check that if I zoom in a little bit, and then the 2 peers, that one, water surface, right? It is not the water we have, it is this one. If I zoom in more, and what is the existing one? Okay, that one. So if we add, if we keep the same condition, right, same boundary condition, and if you add more peers, then definitely your water surface elevation will be increased, because the flow, it will feel constriction, right? So there will be less conveyance area, and definitely the velocity, it should also increase. You can check that. I'm gonna copy this one, I'm gonna copy this one, and I'm gonna paste it there. Okay, if I open the default way, then it is easy to compare with the previous one. So here it is, and we can even compare the values from the table. Let's see if we wanna see the values in the table. The bridge number 1, that is the upstream bridge. If you can check this one, water surface profile, can you check that? What happens, right? Can you check that here? 55.43, now it is 55.49, right? Increased. And what happens to the second downstream bridge? We have that on previous one is 53.75. Now we have the same profile. See, if we check that here, there is nothing happened, right? It is almost same for that cases. Or if I change other condition, right, what will happen? This time I'll do different condition here. I'll add debris, not the bridge. Okay, I'll add more obstacle here. If I open that one, so we have 3 peers. You can add more, and definitely you can see the changes. And now I'm gonna give some obstacle called debris, floating debris, right? Because we have river, sometimes that river carries different types of debris, boulder size material, floating bodies, so that may clog the breezes, right, the flows. During any storm or any flood event, you will see there will be some floating houses, anything, and that may clog the breeze. So this is how we are going to test the effect of debris, and let's see what happens. So how can we add that? Open the peers, and here it is. We can add the same debris, and the size of the debris we're going to add like 30 feet long, and the height will be 10 feet, right? That is the size of the debris for clogging pier number 1, the middle one. And then if I go next, this one, it will be same 30, and the height will be 10. Okay, and for the next one, the last one, it is same 30 and 10. So we increase debris, so our abstraction is more prominent right now. We increase the pier number, we even added the debris, and let's see what happens this time. So I'm gonna even create the geometry as a new one. Here it is, and that will be 2 piers and debris. Okay, and let's see what happens. We have this new geometry. We have to, yeah, we're gonna keep the flow condition as before, the existing one. However, we're gonna change the flow run condition, right? So instead of, so we are going to select this one. However, the flow condition is existing, even though we have other conditions as well. We can select and you can test different combination if you want, but I'm not going to do that. Here it is. I'm going to only change the geometry to 2 piers with debris. And if I want to save the plan, it is going to ask. So that's the 2 piers and debris. Okay. And then the short name will be 100 here as before, and exist with debris. Okay, so making it short. Okay, if I compute, and then let's see what's gonna happen. So closing that one, closing this one as well, and let's see what we're gonna get here. So that's the water level. If I want to add more plans, the existing plan, right? So let's see the difference between these two. Definitely we have, right? When we added our debris, the water level increased a little bit. If I check it there, here it is, and then we have the existing condition there. So definitely when we added the debris, water level got increased, right? So that is the condition we have. If I want to copy that one as before, and I'm gonna save it there, and this time even, okay, I'm gonna copy some cross sections to, okay, copy and compare. So I'm gonna see, you can see that the water surface elevation here for each cross section, and you can see the velocity distribution, and you can even, yeah, copy that one this way from file, copy to clipboard, and you can paste it there to compare. Even you can copy other stations as well. Okay, it doesn't matter what you're going to copy or not. So we are done with multiple conditions, right? So what we are going to do, so what we did basically, we increased the flow rate, we increased the downstream water level, we increased the number of pier, we increased the known water, right? We changed the water surface, known water surface from known water surface to critical flow at the downstream boundary condition, critical depth, right? And then we added the pier, we increased the number of piers, we even added some debris, and we checked the water level is increasing. And if you want to quantify that, you have to go to table, and then you can see that VRIS 1, and previously there is no effect for that one if you add debris, because we are adding the debris at the downstream, right? The breeze, not the upstream one, so there is no change. Can you remember that one? Previously it was 55.49 and the previous one was 55.43. But what happens, right? Let's see, it is also same. At breeze location there is no effect, but in the intermediate location we have that elevation and total velocity. See, these are almost same. That's that. So if I want to change the basic model parameter, which is Manning's roughness for this case, so what will happen? So let's see, and then we'll even change our geometry by interpolating, right? And let's see what's gonna happen. So here it is. I'm gonna change the Manning's roughness, and let's show, okay, see that what is the current Manning's coefficient, right? You have already idea about how to create this geometry, how to insert this one, because I already have 2 videos. In the first part of the video, right, on HEC-RAS, I already demonstrated how to import this geometry from Excel data or survey data. Even we can even create this geometry from DEM data as well. If I get time in future videos, I'll try to do that. So here it is. You can see the left bank Manning's roughness is 0.08, and in the channel it is 0.04, and they're keeping the same roughness for the right bank as well. So what I'm gonna do, I'm gonna change. See, if you want to change this from manually, right, it will take a lot of time, because if you have many, like hundreds of thousands of cross section for longer river, so what are you gonna do? It will take like few days, and you'll feel, okay, I can stop modeling this one. Okay, so we have option that will do the job for you pretty quickly. So you have to know the options here. If you go to GIS tools, or you can go to tools, or you can go to tables, you can check, right? And in tables, if you click that Mannings N or K for Chazy, we're going to select Mannings N. So here it is. You have XS, see, that's why you can see this circle, right? The big circle is selecting every sections. And if you click there, number one, the left bank, and set value, I'm going to set the value as 0.10. It's going to replace everything at once. And the middle one, I'm going to set the value from 0.04 to 0.06. It got changed, right? And for the right one, I'm going to put the value as 0.10, right? It is just finished, matter of a second. And if I save it, I'm going to save it. So press OK. So we have new geometry, means we have new condition, right? So I'm going to save it as new geometry. So we have debris, we have piers, and we have man. Okay, we have new mannings. That's why I'm gonna give new man. And then we have this data, so we have to change your run condition, not the flow condition. So here it is. We have the new geometry with two added piers, with added debris, with new, right, mannings roughness, and I'm gonna use the flow condition as before, and I'm gonna save that plan, and let's see what's gonna get. So debris, and we have the man, and what will be the short name under here, exist, and that will be man. Okay, so if I'm gonna compute, see, definitely this time you'll see big difference. And here it is. If you see that, if I'm gonna show the previous profiles, right, the plans and profiles, the existing one, see how many profiles I have, how many plans I have. I changed like different conditions, right? So these are the all conditions we have. So that's that. See, the 100 here with mannings roughness, it increased. If you increase your roughness, then the velocity definitely it will get reduced, and your water surface will be increased, right? That is the reality. If your roughness is high, if the surface is smooth, then flow will flow, right, faster than before, and then your velocity will be increased, and the water surface will be water surface level will get reduced. And then there's the 100-year existing condition. So I'm gonna save that, and you can see the comparison plot. So that's it. So I saved it. We can see, and you can even check the numerical value, and you can check, right, see that it got reduced. Velocity, previously it was 8 feet, right? That's why I'm saving this one, in order to show you what is the effect of different flow conditions. Previously it was 8 feet. Can you remember the cross section? See, it is 8 feet, and now it's, which one is it? The same cross section, or it is different one? It is different one. I'm gonna select the same cross section. Maybe in numerically it will be a little bit different. We can see that. So what is the name of the cross section? It's Big Creek and the Downstream. Okay, the river section we have. Okay, we can go to the river section. Okay, we can check that. You can find out which one is the river section. That is the upstream of the breeze, and that is the downstream of the breeze. So the upstream of the breeze is this one. Maybe we have different, even though it is showing 8 feet, but you can even click there and you can find out the value. Okay, see, it is, you can find out the value. If you click there, it is going to show the velocity 6.57, and it's going to show you the coordinate as well, right? So actually the velocity got reduced a little bit, and I'll show you the values, numerical values of the velocity. Okay, so after that I'm gonna just paste it before the last one, so that we can understand what is gonna happen. Okay, so let's see the table, right? So let's compare the breeze. So that is the upstream. There is also difference in water surface elevation because we changed the basic model parameter. That is the most sensitive model parameter for any hydraulic model and hydrodynamic modeling. But for hydrologic modeling like HEC-RAS, we have different sensitive parameters. So that's different issue. We're not going to discuss that one here while we're doing our hydraulic modeling. Okay, what I made, just let me grab my water bottle. Okay, so can you see that breeze number 1, and here we have 55.43, that is the basic condition, right? And it increased, right? 56.64 because we changed the meaning roughness, we increased it, we made our surface more rough, right, than before. So that's why the velocity is less, it should be less, and what is such it increased. And what happened to the breeze number 2, the downstream one? See, it also has the same effect, 53.75 and 54.63, right? It's almost 1 feet. And what about the velocity? You can see the flow area also increased a little bit, not a little bit, it's increased significantly. And the velocity, see, is 2.13 and it reduced to 1.6. And you can see the changes, right, at every section. If we add more profile, more plan, you can see, right, if we add all of them together, you can see the difference altogether, right? So that's that. You can even export your data, you can do the analysis for your research or for your project, you can do that, right? It is possible. You can even print, you can write to text file, everything is possible, right? If I'm gonna write to text file and I'm gonna save it right here as a model results, and let's see what you're gonna do, and we have that here. Okay, so I think we can find it from there. Okay, not from here, we can get it from there, maybe. Let's see, we can get it from there. So here it is, HEC-RAS, right? HEC-RAS, big creek, and inside that one we have the model results at once. And you can even see we have that everything we have. We can even check pretty nice output. You can see more accurately for each of this cross section, right? Cross section number, and you can easily make the difference, and you can even import this file and you can make it as a Excel file as well, not a problem. So we have everything ready, right? What I'm gonna do right now, okay, I'm gonna even interpolate. That is the last step I have. I changed everything, right? I don't have anything to see. And if you wanna see the perspective plot each time you run your model, you can go to view, and then you can even see cross section, water surface profile, everything, right? You can see general profile plot, the general profile, you can see everything because I added all of these profiles here, or plans or conditions. That's why you can have access to anything, right? The perspective plot, stage and flow, flood hydrograph, can you see that? For this case, you won't be able to see that because it doesn't have that one. But you can see this plot, right? Rating curve. Rating curve is nothing but the water surface elevation, means the stage, and that discharge. So you can see the change of the rating curve, and you can even plot it. You can even compare, right, which one is which. You can even see that, and you can change the color. You can do everything, right? You can do everything you want, right? It is possible to do everything, right? So that's that. And if you change the label, yeah, you can check this, it is here. So I'm gonna close this one, and then if you want to see the perspective plots, that's what I'm trying to say here. You can see that's the upstream. We can see the breeze, we can see the downstream breeze, and that is the water surface and cross section as well. You can see all these profiles here, right? And I'm gonna do right now, I'm gonna interpolate, okay? And then that will be my last condition that I'm going to show you right now. Then I think I have already covered every combination possible here, and there might be other combination or flow condition, but at this time that is enough, and I'll show the other conditions in my previous I already mentioned that one, and I'll show this one in the future videos as well, and I'll make separate videos on water quality modeling. That's why I'm not going to show anything here, everything here, and I'll also show you something while modeling that sediment transport. Okay, so let me, okay, that is the geometry, and if you want to interpolate everything, you have to go to GIS tool or tools. Okay, and then cross-sectional interpolation, we are gonna interpolate everything. Okay, I'm gonna interpolate first everything, and let me check. Before interpolating, you have to check the distance between these two. See, almost the distance in feet, it is like 750 or 900, whatever it is. So it is that one. So what we are gonna do, we are gonna interpolate these cross sections at 100 feet, right? And then you'll see we have a lot of interpolation. There won't be that, okay, because the distance are not uniform, right? That is what they're showing, right? You can see that it is gonna show you many. See how many? So this time the flow calculation will be more accurate, right? You can see the bend of the river and everything. If I save it, if I show the table of meanings roughness, it's already interpolated and everything pretty nice and clear. Okay, so now I'm gonna save it as a new geometry. Save the geometry as new, and our new meanings roughness, existing geometry, no, that will be new geometry, means interpolated. Okay, interpolated geometry with 2p. Okay, what I mean it because I was maybe muted, so that's why what I did, I just saved this and then I run it. Okay, and then I'm done with the simulation because it took a while. See, 3 seconds, and now I'm gonna show you everything. I'm gonna open it. See, now it's pretty nice, and you can see we have many cross sections. Even you can't finish everything because we added a lot of cross sections there. Can't finish, right? So I'm going to show you the long profile this time. That one, see, it increased a bit because we added every condition, right? And if I'm gonna show you the previous plans as well, the first one with the new one, new geometry, and you can see the difference between these two. Okay, because we added our debris, we added new meanings roughness, even we added everything, right? So that is the existing 100 here with interpolated geometry, and that is the existing one. And if I want to compare, right, with the previous one, let's see if I can do that. Okay, I'm gonna open it again, and that, okay, so copying, and I'm pasting there because that was, right, the profile when we added new meanings roughness with interpolated geometry. And now we have this one. Can you see any difference? We can see that if we open our table, now let's see for bridge number 1, can you see that? Because we have many, right? The bridge number 1, see, it got increased a little bit, right? Previously it was less than that because the interpolated cross section, it is calculating more accurately and it is giving us more accurate results. So that is the benefit for calculation. And there's the breeze. Previously it was different, right? No, maybe 6.4 or something like that, but it 0.99, it increased more than 1 feet this time. Previously it was close to 1 feet, less than 1 feet, but now it is more than 1 feet. So this is called interpolation, right? If you want to interpolate everything within a ridge. But what happens, right, if you want to interpolate, for example, you have a breeze there we have a breeze, and you are gonna interpolate, right? You're gonna interpolate in between this section 98859 and this one 9395305, because that is the main station, right? Main cross section, surveyed cross section, one cross section before and one cross section after. So I'm going to interpolate everything from this one to that one in between these two cross sections. So let's find that. Okay, go to tools, interpolate in between two sections. So what will be the section number? 95. Okay, that one, this section, find that section. It is 9559. okay, that one 98859. that is the upstream, and we are gonna see, you can see that here, the breeze and the cross section, you can clearly see that. So that is another one we are gonna interpolate, right? So that is pretty nice. And number of feet we have, the distance between these two is showing 97 point this one, this cross section we have. If you want to interpolate like 20 feet, right, or 10 feet, okay, 10 feet, okay, 10 feet, because we need more accurate result, right? We want that. And that's it. So yeah, see, we have more accurate results. And what is gonna happen next? If we even, okay, we are gonna even delete. Okay, if I wanna interpolate in between these two, then what will happen? See, we have so many cross sections, and it will give us pretty nice calculation, right? And I'm gonna even interpolate in between these two. That is another options we have. So these are the options you can use for your real world engineering cases. And let me find that. Okay, that's that. If I gonna select next, it is next, and in between these two, and we have 100. So I'm gonna even keep the same distance we have, 10. Okay, so we have pretty nice shape, right? Pretty nice shape of this. Can you see that? Definitely you can see that. And what I'm gonna do, I'm gonna save this geometry, and I'll show the result as well. Save the geometry as, we have the Manning's N and Devries interpolated geometry, and okay, I'm gonna making it short, interpolated geometry. Okay, interpolated geometry, and then finer, okay, finer one. And I saved it already, and let's change the run condition. Steady flow analysis, it's finer, existing condition. I'm gonna save the plane, and then that will be interpolated geometry. However, Manning's and Devries, everything will be there, but I'm gonna keep it finer. Okay, and the short ID will be year, and then exist and finer. Okay, and let's see what's gonna happen. It's gonna take a while, hopefully, because it is more finer than what we had previously, right? So still it is so fast, and you can check, right, this one, and you can check the flow profile as well if you want. And in the breeze location, you can see even the water surface elevation is increasing. If you want to check the planes, we have the existing one, you can see the difference between these two, right? And we can copy that one, and we can paste it. Each time we are gonna copy, we are pasting it, and we're comparing, right? But you know, naked eyes, we can't even see the difference between these two. And now let's find out the difference between these two. And if I want to even plot the previous plane as well, let's use that. when we interpolate it, but without this finer interpolation. We can see it's kind of a little bit, right? Still we have the rise of water surface elevation, and we can check that when I interpolate it. Can you see that it was the downstream breeze, right? So find that downstream, finer. Where is our downstream breeze? Maybe it's there. This is the breeze location. Okay, we passed it. Maybe let's find that. Okay, I'm increasing the view so that we can find, that is the breeze. I can see, right? That is the breeze. See, previously it was 7.5 and there's nothing happened, right? And in other stations, what happened? Is there any change? A little change we can see, a little bit, not that prominent change we can see here. So that's that. So interpolation won't work for this one. It is same because the hydraulics is pretty simple. So interpolating this cross section won't help us that much, so we don't need to do that. So you can check this way to take your final decision that, okay, if I need to interpolate, it will give you more accurate result or not. So these are the different combinations we already mentioned, and you can see here we have this more, right, pretty nice look of this one. And if I want to change the view, you can see we have many, literally have many, right? Okay, that's that. So I'm gonna finish off here, and you can practice by yourself. I'll give you this link in the description below. You can even find the initial flow condition with this geometry, and you can change it by watching these videos, how I just changed it. And you can add more conditions, and you can test your, to learn. Okay, since you are learning, maybe you are learning this software package, so it's pretty useful, and you can even explore all these options so that you can even apply that for your, right, for your project, for your research, whatever you're gonna do, you can do that. And let me know if there is any problem, I can, so that I can help you with that one, because I'm still learning, because I'm using this software like for more than 10 years, so I am a little bit familiar with this one. So I can set up this model, and I apply this model for real world cases, for designing or for analyzing morphological analysis of different breezes and different soil, even salinity issues, water quality issues. And I applied this model for estimating environmental flow of a river, for a very long river. And I also applied this model for sediment transport analysis. I'll show that one in my future videos as well. So thank you very much for watching, and practice by yourself, and stay safe. See you in the next tutorial. Thank you very much. Bye.